Okay. So is it? Can you see my screen? Surinder ji, visible hai na?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay,
Visible.
okay, 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 okay. Thank you. So the topic on which I am going to have a discussion with you guys is computer-aided design in 3D printing and additive manufacturing, and I'll be going through the essentials of this technology and then taking you to the current state and research challenges. The topic, although seems to be a little bit on the sidelines of the topic of the AICT sponsored SCTP on advances in manufacturing technology, that is the CNC and robotics. But when we have the 3D printing, so that is more or less we can compare the process with the CNC technology also, because the 3D printing or additive manufacturing machines, they are also numerical control machines. Okay, so this is what I have to say about this. And uh, okay, so this is my presentation plan. Uh, I'll be first going on to the topic of 2D printing and taking you to the 3D printing, what is the similarities and differences between the two. Then second bullet is I will be discussing the additive manufacturing or 3D printing overview, and followed by CAD requirements for 3D printing. And thereafter, I will discuss CAD processing for quality prints and research issues in CAD of 3D printing. So let me first go to the first bullet, that is 2D to 3D printing, how the things are evolving or how the things have evolved in the past few years. 3D printing is very well known today, but it makes sense to have an idea of 2D printing first and then compare or create an analogy between 2D printing and 3D printing. So in 2D printing, what we have is a picture is divided into a number of square elements in two-dimensional plane. Okay, so each square element is known as a pixel, or which is we also call it as a picture element. Okay, the frame or the set of pixel information is digitally communicated to the printer, and for each pixel we can control the level and color of the ink, and the same thing is communicated to the printer, and that we get a print of that print soft copy of the print accordingly from the printer itself. Okay, so we will see this with the help of this example. For example, this is a picture which you can see, and this is totally the frame of the picture. The total this rectangle is the frame of the picture. Now, this picture has been divided into number of small squares. Okay, so if we focus on this small part which you are seeing over here and further zoom this area, you will get small squares like this. So this color, each square is having some kind of a color and the intensity of that color basically. And this is down to this 1 pixel. Okay, so for each pixel we have the information in the soft form, and that information is sent to the printer. So this is what we have, the picture frame, okay, or the frame buffer. So in this picture frame, you can see that this is divided into say 11 plus 1, 12 into 8 pixels, okay. And normally this is taken as the top left corner of the screen, or the picture is taken as 0, 0, and here it is the maximum. So we can designate in this the every pixel is basically designated with some kind of a coordinate. So in this case, this is 3, 5. So 3 is along this axis if we take it as x-axis, and here you have the y-axis. So this is 3, 5. And if you take the this other way, like this as 0, 0. Okay, this is 0, 0, and x-axis moving towards this and y along this. So this is 3, 5. So this is both the ways are commonly used, but this is most common where the top left corner is of the picture is taken as a 0, 0. Okay. Now, the quality of the 2D print depends upon the resolution. The lower is the resolution, the lower is the quality. So low resolution means for per square inch or per unit, you have less number of pixels. And higher resolution means per square inch or per unit area, you have more pixels, okay, picture elements. So in this case, you can see in this area, the same area, you have 3 pixels per unit. That means 3 into 3 is 9 total pixels. And here you have 9 pixels per unit, which is 9 into 9 is 81 pixels in total. So you may have seen this kind of pop-up window that comes up when you try to save some picture or try to give some actually print command, and you get this kind of information which is you need to input to the computer, to the system, so that you can get your print accordingly. So needless to say that more is the number of pixels, more memory requirement is there. So here you see in 2D printing, you have a grayscale bitmap, which has a values of 0 to 255, also called 8-bit. That means 2 raised to power 8 is equal to 256. So each pixel is given some kind of a designation between 0 to 255 if we are talking of a grayscale black and white images. Okay, so here 0 means black and 255 means white color. The values mentioned in between are the mixture of black and white. That means some kind of a gray. So that is how you see certain variations in the picture in black and white. So that is why we call this kind of grayscale images as 8-bit images, because you have 256 values within which you can vary the color. That is the black and white color or the grayscale color. Okay, so in colored bitmap, we have 16-bit. That means the 24 or 24-bit encoding. So here we have, instead of black and white, we have, in place of black and white, we have mixture of 3 colors, that is R, B, and G color. These are the basic colors, and for each color you have 8 bits. So 256 options for red, 256 for blue, and 256 for gray. So for each pixel you have this information, and when these colors are mixed in this quantity, you get some color for that mixed pixel, and accordingly you divide the whole of the picture into so many pixels, and for each pixel basically you have some kind of a color, and together you get some a holistic view of the picture itself, pixel as you add together all those pixels. Okay, so coming on to the 3D printer, moving towards the 3D printer from 2D printer in the slide, we discussed in 2D printing, what do? You create a file, and just like a Word file or some kind of a PDF file. You create the file is submitted to the print device, and file is printed. So something comes out of the printer, which is whatever information you have, the pixel wise information of the page that you send it for printing is printed by the printer, because the printer knows that what quantity and quality of the quantity of ink is to be mixed or thrown out on that particular pixel. Okay, and similarly in 3D printing, the file is created. The file is submitted to the print device, and file is printed. Okay, item is finished. That means you have to remove some unwanted materials, and you get a part which is a 3D printed part. So both require digital image to be divided into manageable elements. Okay, so if you want to further look into this specs, you can you can go for this resource which is available. Why 2D printing is like 3D printing, a counter and jump over. So this is the link which I will share with you afterwards. Okay. Coming on to the additive manufacturing or 3D printing. So what does this basically means? We just saw the comparison that this is almost the same in both the things, in either in 2D or 3D. You create some kind of a soft copy, you send it to the printer. Either it is a 2D printer or a 3D printer, and you get a 3D print. So what actually additive manufacturing or 3D printing is? Additive manufacturing is the official industry standard term as per the ASTM F2792 standard for all applications of the technology. Okay, so this is the term which has been coined under that standard. It is defined as the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing methodologies. So you may have gone through or taught somewhere the manufacturing processes course or the machining. You already know about the machining and all these things. So there we are having a block of material, and we with the help of some tool you reduce the material from that to create a certain shape or a given shape or a desired shape. So that is what we call it as the subtractive manufacturing. So, but here we are talking of the 3D printing or additive manufacturing is different from subtractive manufacturing. So here we are adding the material layer by layer, say with the help of some powders or polymer, which we use, and we create the print of the part, print of the 3D print of the part from scratch. We are not reducing the material from, say, a block of metal or something. Okay, so this is just to give you a picture, a view of what a 3D printing is. So this is done with the help of machines, whether it is a full-fledged additive manufacturing technology machines, okay, or some kind of a small 3D printer. Okay, so in this, you have certain advantages when we talk of 3D printing. You get very parts with very intricate shapes. So remember, this kind of a 3D print of such a complex part otherwise requires mold to be prepared. For such a part, if you try to make a mold, it is going to cost you a couple, maybe lakhs of rupees. Okay, and if you want to create some kind of a prototype, okay, you can create it with the help of 3D printing. What you only thing is need is to have a 3D model of that part and send it to the printer, just like we have a Word file or something for a 2D printing or a PDF file, and we send the file to the printer. So this is what we should have in this kind of a printing. So very intricate shapes can be made with the help of 3D printing, even without the requirement of a mold, which is very costly. 3D printing has been used successfully to make parts of various sizes. So whether it is a big part, as you can see in this figure, or a small part like this, you can make it with the help of 3D printing. Geometric complexity is not a limitation in 3D printing. You can see this kind of a part. This is almost non-manufacturable, I will say. In conventional manufacturing processes, even a die would not be able to make this kind of a part, or even machining is not possible to make this kind of a part. Okay, so this kind of a parts can be made with the help of 3D printing very easily, because the only thing you need is the CAD model and submission of that CAD model to the manufacturing machine. Okay, so these are the technologies that we have in 3D printing. One is fused deposition modeling. Then in fused deposition modeling, just to give you a brief, is you have some kind of a filament, and you melt that filament slowly and deposit the material which is molten to the areas or to the volume elements which are required. Okay, so where you require the material to be present. Okay, so layer by layer, actually you go on building the part. And stereolithography is again a kind of basically layer by layer you have some kind of sheets, for example paper sheets, and you cut the sheet according to the geometry of the part which you want to build. For example, you have a bunch of papers, okay, a bunch of papers, and you cut piece of so many pieces of papers and give them a particular shape and join them together. This is just like that. So the only thing is you are cutting those papers layer by layer. Selective laser sintering is where you have some kind of a polymer which is spread on the platform, and with the help of laser you you actually center those powders so that they join together. The specified area is centered so that they join together, and rest of the area that remains as powder, which later on you can remove. Then once that layer is solidified or centered, you again spread some kind of a material layer, powder layer, and again center it. So two layers join, and then you bring the third layer, fourth layer, fifth layer, like this. And in selective laser melting, this is basically used for metals and all that. Instead of sintering is you are not actually melting the material. Here you are actually melting, because some of the materials they won't be joining with sintering, so you need to melt those materials. So in this the concept is the same. You have the powder spread as a layer, say 0.5 layer, and you uh, provide a certain source of heat, maybe laser or electronic source, just like electronic beam melting, and you deposit the material in specified area, and rest of the area the powder remains as such, and you again build the solid layer by layer. Electron beam melting is when you are making use of, instead of laser, you are having electron beam. And then you have laminated object manufacturing, where again, just like stereolithography that I discussed, you have objects, and you laminate those objects layer by layer. So there are n number of processes, and the technology is evolving day by day. It won't be possible to discuss each and every 3D printing or rapid prototyping process over here, and which is not in the scope of this lecture. But you can always go through the sources available and see what kind of 3D printing or rapid prototyping processes are available. Okay. And this is what I was discussing, the fused deposition modeling, FDM. Okay, so you have this nozzle, and through that nozzle, the filament is coming. This is a plastic filament, maybe PLA or ABS material, or some other material which is suitable for 3D printing. You heat this nozzle at the end. The material liquefies or melts, and it deposits a layer, this kind of a layer over here, and then afterwards you lower the platform, and or you to raise this nozzle by a bit, and deposit another layer, third layer, fourth layer, and you in the end you get some kind of a material which is produced, component that is produced. Okay, and this is the fused deposition modeling, where you have, instead of one roll, you have two filaments, and you can what you can get here is the multiple colors. Okay, so multiple colors, so instead of one color you have two colors. You can manage, because when you have the CAD model with you, you have provided the color information. The computer knows that where to deposit which kind of material, just like in our color print, when you have give the command to the printer in 2D printer. Okay, and the photograph or whatever you want to print comes out with nice colors, because the soft copy you have all the information about pixel by pixel, that which pixel which color is needed. So same is the thing here. For each volume element or each layer, you have the information about which color is to be deposited in which area. So this gives us a multicolor print, and you have more color print also. but I'm skipping that. I'm not included that in my slide. Here you see you have the stereolithography. Instead of the depositing the material, you have a liquid. Basically, liquid is there, and you bring the laser wherever it is. You require that polymer, liquid polymer, to be printed. For example, this is a liquid, so you have this layer. Okay, so this platform is say at the top first. This one, when it was at the top, you bring the layer laser. You scan the area, the desired area with laser, and that area is solidified. Then you lower this platform, and the next layer of the liquid is solidified, and this way you are building the material. So this is a stereolithography. Then you have another one, selective laser sintering. So instead of the liquid, you have the powder here. So you again have the laser source, and laser source deposits actually scans the area which is required to be solidified, and layer by layer you are going to print that material. Okay, so this is the powder bed first. So first layer of the powder, then second layer of the powder, third layer, and all that. So layer by layer you are using the material. So here again, in this, you have the liquid instead of this. You have the powder instead of the laser. You have the liquid adhesive supply. So you have the powder bed, and this is known as powder jetting. That was not okay. So powder jetting. So here you have the powder layer, and you sprinkle some kind of a liquid adhesive, and the area is solidified, and then you bring the next layer forward, and this way you have the complete solid coming out of it. So you can see here that the leveling roller. Okay, so here this is used for spreading the powder. So once that layer is solidified, the next layer is this roller comes and spreads the powder over here. So this is there in all the powder kind of technologies, whether it is SLS or powder jetting, okay, or SLM, same thing. The roller will come and spread the material over there. Okay, and here you have the laminated object manufacturing. Here instead of the powder, you have a solid kind of sheet. Okay, so solid sheet is there, and you have this cutting of the sheet with the help of some layer. You can see over here that this area is cut out of the sheet, but you can imagine that a lot of material is wasted in this kind of technology, laminated object manufacturing. And there are these aspects also which need to be looked at, that what will be the wastage of material if I go for this kind of technology, and which technology is suitable for the part which I want to make. Okay, uh, these are the just an overview of the CAD, this 3D printing technology, but a lot of other technologies, as I said earlier, are available, but not in the scope of this presentation. Okay, so here you have the CAD requirement in 3D printing, because we said that the CAD model, you send the CAD model and the printer will print. But what actually happens with the CAD model is very interesting to know. Okay, so here you see a small, simple, very simple part which is having a cuboid shape, and inside it is having some kind of a hole. Okay, so you have the creation of a 3D CAD model, and once that CAD model is available, the 3D model is available, you triangulate that model. Triangulate that model means that each and every face of this solid is converted into triangles. Okay, as you can see that this front face of this one is divided into two triangles. You are seeing two triangles, one triangle this one, and another one is this one. Similarly, the back face is also divided into two triangles, but I am just talking of two triangles. It may be multiple triangles when you make a 3D this triangulation. Okay, so inside where you have the curved surfaces, you are seeing very small triangles, because curved surfaces for approximation they need uh, small triangle, small area triangle. Otherwise, if you make a big triangle over here, because triangle is always a flat surface, okay, so it will give you poor approximation of the surface. Say here, big triangle will serve the purpose because this area is flat. Okay, so we'll come to that also. And once this triangulated model is available, you are going to create multiple slices of that CAD model by cutting this CAD model with the help of planes. Say in this example, you see 1, 2, 3, and 4. This A model has been divided into 4 layers. For each layer, you have the outside and inside areas defined. When you have cut each the solid model with some, just like you take a knife and cut it, just like imagine just like that. Okay, and once you have that information of outside and inside areas, you now this printer knows where to sprinkle the material or where to throw the laser light. Okay, and wherever the material is deposited, that area is solidified and other areas remains empty. For example, you have the powder layer over here for this or this for this upper layer, and you bring the laser, you throw the laser uh, uh, in the specified area. Those specified areas qualified. The rest of the area where you have the powder, but you don't bring the laser for sintering, remains powder as such. And you remove that powder afterwards, and you get a powder. So this is a physical model that you will get. Of course, there will be some approximations and some errors. This is the digital workflow. Okay, this is the digital workflow for 3D. So what are this CAD requirements in 3D printing? How we can improve the quality and all that? One thing is you have seen this previous slide is once you have the CAD model, you need to do the triangulation. Okay, and smaller is better. So smaller is the triangle, better it is. More larger is the area of the triangle, it will require higher approximation and higher error. Slanting faces. So we'll come to how slanting faces they affect the quality. Vertical faces are better in this case. And when you have the slanting faces, then you have the slice thickness. Thickness is suppose this part you instead of 4 slices, you have 10 slices, 12 slices, or maybe 20 slices. You get a better part because you have more approximation and better approximations of. Then you have part orientation. How you build the part. For example, this part instead of keeping horizontal, keep it vertical. Okay, so that will also affect the quality. We'll see how. So, for example, this is the CAD, simple CAD model because from understanding point of view, I made it simple. So you have the CAD model which you can make in SolidWorks or Pro or CATIA or NX, whatever software you use. Okay, so this CAD model, you have all this surface information. You convert it into triangulated model or STL file, simply to save as STL file. Okay, so you have this triangulated model. You can see this surface has been divided into 2 triangles. This surface also has been divided into 1, 2, 3, 4, 5 triangles like this. So these triangles are 24 triangles. Okay, so you can see in the and this model has been generated in SolidWorks. So this kind of information you will get when you generate that. Okay, and once this is you have the other models, you see this is all surfaces are flat, so you need not to worry. So you have perfectly representing the same CAD model because everything is represented well. Because I told you that once you have the flat surfaces, the approximation is perfect. The moment you make instead of a flat a curved surface, okay, so you need a more number of triangles or smaller triangles. Okay, so here you can see that this surfaces have been created into triangulated or STL file has been generated. Okay, So this surface is two triangles. Here also one big triangle and then small triangle, just to match this one, because this is curve curvature is here. So you have smaller triangles to match these triangles. So you have smaller triangles here too, and here again big triangles. And here you can see 48 triangles. So this is better approximation. Okay.
Sir,
Now, yes.
sir, I want to know that why we divide all the faces in triangular shape only.
Okay. So this is because triangle is the simplest form of representation when you want to represent a surface, basically, or a plane. Okay. So because three points, triangle has 3 points. Okay. So you don't have anything which is lower than a triangle to represent a plane. Okay.
Okay,
And
okay,
if you go for say quadrilateral, so you have 4 points, then your model becomes more complex, and your computations, because you want to cut each your geometric model with a plane. Okay. So because I am going to what I am going to do, I have this model, I have triangulated it now. For example, you keep this model as such. Okay. Okay. And you cut this with a plane. So this is easy. You get some kind of a information of slice. For here it is up to here it is easy. The moment it comes here, you need to have the intersection of a plane with a cylinder. है ना? Yes, this is
yeah,
a
yeah,
cylindrical area. So you have a cylindrical area is difficult to actually get the intersection with the plane. Or if you have, for example, cylinder and cylinder is more complex. So basically, we want to minimize the complexity of computations. So that is why we want to keep it. I will show you in a slide later. That is with the
okay,
help of some figure. Okay.
okay,
So
sir.
yeah. So in slicing, you have this slice. For example, this is a cylinder basically. Okay. And you have these many slices. You see so many rings. So it is perfectly. It is all vertical. Okay. So the moment you change the shape from perfectly cylindrical to some kind of a curvature, so for each layer you have this kind of information. So next layer will be somewhat shorter, and you get some area which is left out. Okay. So you have a bigger slice, and here say the lower and next slice, third, fourth, fifth, and this is the area. This is the error which is going to remain when you create your 3D print. Okay. So that means the more is the number of slices in this case, this area will be less. So for example, you have instead of this much thick layer, you have two layers instead over here. So you will have better approximation of this outer profile. Okay, got it? I think so. This we call also call it as cusp height or staircase effect. So you get some kind of a staircases. है ना? So staircases are you are actually not matching the exact profile of this shape. So this slanting faces they cause error in slice. So if you have perfectly vertical faces or curved faces, you can see the comparison. Now, so this is staircase effect that has been shown to you. Okay, so um, this is the arithmetic means of how you are deviating from the average. If you draw a line in between, you know, and take the area, the length from this corner. So that is what we call it as the arithmetic mean deviation. That means that parameter, how you actually evaluate what is the accuracy of your 3D print that you are going to create. So these things you can manage in the 3D CAD model only, because this has nothing to do with once you send the model to the manufacturing, because once you have sent the model to the manufacturing after slicing, have already fixed the staircase effect, and rest of the things are the accuracies levels are determined by the accuracy of the machine. But as far as the staircase effect is concerned, you can control it in the when you are sending the CAD model to the machine. Okay, before sending the sliced CAD model, you should be aware of these things. Okay, so but you see, the more is the slices, the more time it is going to take you to build the part, because more layers, more scanning and all that. Okay, so you have to compromise or optimize between these things. Okay, so this is a bigger layer, 0.2 mm layer, and you have 0.1 mm layer. You see, the accuracy of this model will be much better. Size, thickness, that affects quality. Now, the part orientation. So you have a very simple part, this one, cuboid and its cylinder. If you are keeping it vertically, that means building like this. So this is going to give you uh, error due to triangulation only, because when you triangulate this, there will be some error in triangulation, approximation. Okay, so that is the only error, because otherwise your this thing is perfectly okay, because you are keeping it vertical. The moment you keep it here, okay, so like this same model like this, so this is okay for cuboid, it is okay, but for this curved part, you can very well imagine that the slices will give you some error, है ना? जैसे मैंने पीछे I showed you previous in the slide. If you keep it vertical, so this is okay, and when you keep it curved, you are getting some. So same thing happens. Okay, so error due to triangulation का तो आएगा ही आएगा, but you will have slanting edges error, so because you are keeping it some other orientation. So part orientation also affects quality. Okay, so as a brainstorming, so CAD requirement, so you have this kind of a model, so which build direction will you select for this model? So the first one or the second one? Can you, some of you, throw some answer? Yes, anybody? So if you have this model, so which way you will keep it? The first way or the second way? When you want to 3D print it?
First, sir.
First, yeah, natural. So when you keep it first, so everything is going to be straight. When you cut it, imagine when you are slicing it, cutting it with the knife, it is going to be perfectly circular, like this. So suppose 10 layers, 10 layers you, if you keep on the top of that, it will. So here, if you cut it and straighten these edges, you have to straighten these edges also. No? So this will be some staircase effect. Okay. So AM compatible, coming onto the AM compatible or additive manufacturing CAD formats. So you have a number of CAD formats. Feature-based models are there. You may have worked in SolidWorks, CATIA, or some other CAD modeling software. You have some extension of that CAD model available when you save that part model. So generally it is wildfire, it is say .prt. For SolidWorks it is .sld something, SLDM. Okay, and that is a local or the native format. Okay, so which is not directly suitable for your 3D printing. And again, you have BREP formats. So BREP formats are just like a step file and IGS file. So these are the extensions for those file formats. And here you have the total outside boundary information. You don't have any information about how you created that model and all that, because you build the model or the CAD model feature by feature. Okay, and okay, if you have worked on SolidWorks or CAD modeling, so you know that you have extrude feature, then extrude cut or pad feature. So all these features are used to build a solid model, okay, or a CAD model. So once you have that CAD model, you save that as a BREP format, either as STEP or IGS, so that you can take that model into some other modeling software, CAD modeling software. Okay. Now, AM compatible, these file formats, they are not directly suitable for uh, 3D printing. Okay, so you need to actually convert these models into AM compatible CAD formats. So the most common format is the stereolithographic format of .stl. So, Jo, I showed you the previously the slides where you have the triangular spaces. That is nothing but STLs. If you have created if you have some curiosity, just try to create a small cuboid in a CAD model and try to create its STL file, or you will see the triangles. Then you have the similarly OBJ, AMF, and 3MF formats. So 3MF is a file format which is the latest one. Although STL is doing well. Till now we are using STL. But as we go on developing technologies in 3D printing, lot of innovation is happening, research is happening. So people are moving away from STL to 3M, and these are other file formats. But still, 99% still now we are satisfied with STL. Okay, but for some other limitations of STL, we are moving away. But as of now, 3 STL file is good enough. Okay, so you see, that was a question, I guess, by whom was the question? Can I know the name, please? Piyush.
What, sir? Yeah, yeah, yeah.
Piyush, you got that question. Okay, you can see. So this is a plain AM compatible file formats. So you have this. You see, you are cutting this, slicing this, and you are getting this area. Basically, what do you want when you are 3D printing? 3D printing, you want the area where you want the laser to be scanned. You need the outside as well as the inside area so that the laser can scan that particular area. That means the outside boundary is fixed and inside. Here you have only the outside. So that means the whole scanning will go throughout this rectangle so that the part can be built. Okay, so this is the plane intersection is easy. Okay, now here comes a plane cylinder, this intersection, complex competition. Okay, because you cylinder, you see it has quadratic equation, plane here is a line, linear equation. Okay, simple. So you have complex competitions. The moment I divide this into triangles, now this area again, this is very complex. Just to compare the two. So this is again plane intersection, because now you have replaced this cylinder with small planes, many planes. Okay, so you will get this kind of a plane area or the outside area information with this slicing. Okay, so this I hope Piyush answers your question. And why we are going, yeah, you can divide this into say rectangles. Rectangle में भी कर सकते हैं इसको, but why we are not doing it? Because it is very easy to represent a triangle. Only 3 points can represent a triangle. But if you have, the moment you have a rectangle, you have 4 points, then you need to understand. See, in this triangle, suppose this is point 1, P2, P1, P2, and P3. So I know that P1 is to be joined with P2, P2 with P3, or P3 with P1. There is no other option. The moment I go for rectangle, for example, this rectangle, you have P1, P2, P3, P4. Now you need to remember their order also. Okay. So how you want to connect? If you by mistake connect P1 with P3, you get something else. It is not a rectangle. So you need to remember the order, or you need to remember means you need to save this information in the computer. And once you do that, so that means the complexity is more. So to avoid that, and triangulars, they serve our purpose. So we go for triangulation, and that is why it is very commonly used format, stereolithography. So this is the layer information is obtained by getting intersection of layer plane and triangulated plane, just like I showed you in the previous figure. Because of the triangulation, STL file is the most accepted format for 3D printing. Okay, so you have just like a cylinder if you want to build. So if you have this outside area and inside area, I will see like this. But if you have a triangulation, Instead of these circles, you will have this much. So then afterwards you can know that this is my outside area and this is my inside area, and this is the area where I want the material, whether it is SLS process or FDM process. You know the area, basically the outside boundary and inside boundary, and you are not going to sprinkle any material outside this area or inside the inside boundary, which is okay. The only thing is you have lines instead of complete circle. You have small lines. So small is the triangle, the better is the approximation. Okay. Now, they AM compatible CAD formats, the STL file, they provide the planar information. It is not suitable for complex parts such as lattices. So remember, we are now moving towards high technology like printing of orthopedic implants, just like our replacement of some femur or pelvis or something, which you want to 3D print basically, because they are customized medical devices such as a replaceable orthopedic implants. Okay, so what you have is a CAD model of the patient's this thing, the the what do you call that, as say bone, okay, femur. So you have the CAD model of the patient's area which you want to replace, and or the bone which you want to replace, and you convert that into say CAD model, CAD model to STL file, and print it, maybe titanium or something, with the help of a machine, 3D printing machine or a AM machine. So it is not suitable for complex parts. So sometimes you want some kind of a lattices, you want to keep some area open, and that is not very comfortable in conventional STL file. Then the capabilities of additive manufacturing techniques is increasing day by day, multi-materials and complexity of the materials, which is not very easy to be done with normal STL file. So new AM techniques are being developed. So new AM techniques like where you can print materials which are having more capabilities, okay, multi-materials, okay, meta materials. So these materials are to be the CAD model is to be represented accordingly, okay, because this is the only process which you can't do without a CAD model. You can do everything on the world without a CAD model. Even CNC machining you can do without a CAD model. You can make a part program, but in this nothing can be done unless you have the CAD model. So new AM techniques are being developed for addressing issues like composite materials, functionally graded materials, or meta materials. So that is why you need new CAD format. So why does it matter? Reason one, the file formats decides what information goes to the 3D print. Okay, so 3D model, if your 3D model is not good or not representing the information, suppose you have composite, so you have a 3D printing material, you have a CAD model which cannot accommodate composites. So there is no fun of sending that CAD model to the printer, which is have very high capabilities. Okay, so this is why AM compatible CAD format is very important. That means the compatibility of the machine. That means your machine is having good capabilities, but your CAD model is insufficient. So you have the non-compatibility or incompatible. Reason two, the 3D printer file formats and tools are tightly coupled. Okay, so 3D printer file format that you create and generate, and the tools, they have the high connectivity. So this is required. So AM compatible CAD format is very important. So these are the formats. STL formats. This is the stereolithography. You can generate it. You have all the models once you open SolidWorks, for example, and you have all the save as जब आप करते हो उसको, you get these options: STL or OBJ, AMF, 3MF, and others also like VRML. So these are the formats which are available to you. The options are available to you. Okay. Now here you have the simplest open source file format is the STL. STL. So this is the simplest open source file format. You have two options like ASCII and binary. So ASCII is basically in you can if you save as ASCII file, you can open the file in the notepad and you can see the triangular information. Maybe if time allows, we can see afterwards in what is the ASCII and binary. So binary is the model is in terms of 0, 1 and all that. You won't be able to understand yourself. But ASCII file you can understand कि उसमें triangle का where is the like triangle 1, what is the point 1, 2 and 3 and what is the outward normal. This is how you define a triangle in triangular information or surface information in a STL file format. So what are the limitations? It cannot store any intersecting objects. Okay, and no information about material, color and texture is available, and complex parts require large number of triangles, making the file heavy, and this is another disadvantage. Units and scale information is not available in STL file, and editing and converting is difficult. So this is why you want to move away from STL file. But again, I am repeating, 95% of the cases, the STL file is good enough. So most parts require single color printing. Hence, it is very common. Okay. Now, uh, coming on to the OBJ. So in OBJ or object file that we call it as, the second most widely used file format, and it is originally used for 3D of 3D printing of by graphics designers. They basically used to 3D of graphics by for graphics like just animations, movies, and all that. So now used for 3D printing in industry also. And these are the features like this is open source and simple. There is an option of triangulation or free-form surfaces. So you can have two options. And then you can store color and texture information in a companion file format called material template library format. So you have basically instead of one file, you have two files. So one file is the geometric information, other file is the material information. So you have the .obj file and an MTL file, two files, and you have the pair of files can render a multiple textured model. So this is the details is given in this link if you want to go further in this. And this is again a multicolor OBJ file, multicolor texture and material widely used in aerospace and automobile industry. And it saves complex files, free-form surfaces, keeping the file light. Okay, the total memory requirement of the file is less. So limitations are pair of files. You have instead of one file, you have to manage two files. And repairing is sometimes your data gets distorted when you are getting transferring the information, and you sometimes want to repair that so that there should not be any kinks and all that in the model that you want to send for 3D. So repairing of the information or data is difficult. Okay, now this is the AMF format. So AMF format, as you can see, it is the additive manufacturing file format. It is also known as STL2. Okay, the later version of STL. It is again an open standard for describing objects, additive manufacturing or 3D printing. The official, this is defined by official ISO ASTM standard, which is given, and it is in an XML format. Okay, just like you when you may have submitted your income tax return sometimes. Okay, yourself. So the information is converted into XML format before it is submitted to the income tax return. So it has certain fields, and each field is specified as your total income, the total deduction, and all that. So that is in XML file format. So similarly, the information here is stored in the XML file format, and And you have native support for geometry, scale, color, materials, lattices, duplicates, constellations, just like you see this model. So you have the lattices and constellations, so very complex model, because each and everything is very minute details. Here it is a solid model, only the colors and all that. Okay, so here it is very complex. So such kind of constellations and lattices can be represented. Okay. Now, here you have the AM compatible. Again, you have the AMF format. Can also use curved triangles in this case, and keeps the file size light. Became ISO standard in 2013, and industry had been slow to apply this because of this reason, that SolidWorks and only the SolidWorks and Autodesk Suite supports it. Status, which is a 3D printing manufacturing company, means manufactures machines, additive manufacturing machines. Okay, Status has also signaled its cooperation, even though they might move away and focus on 3MF, which is the next format I'm going to discuss. And because the Microsoft, they came up with a new consortium, where uh, we are going to have a consortium of different companies which are investing in new developing a new file format which is acceptable to CAD system developers, and just like Dassault system, so that it can be incorporated in CATIA and all that. And then the machine manufacturers such as Statuses. Okay, so STL 3D printer file formats will be replaced eventually. We don't know if AMF or 3MF. So either it will be AMF or 3MF file format. But still, because I keep on saying that STL is still good enough, but we need to discuss about what is how the things are in. So this is the last kind of file format, AM3MF. Okay, so it was originally started by Microsoft as a proprietary software. Okay, now they actually then made it open source and made it kind of a consortium, so that other companies they can join, pool their resources, and it gives it more complex acceptability. So it is a consortium of big industry stakeholders like 3D systems. They are again 3D printing or additive manufacturing machines. They develop or manufacture the machines basically. Then you have other manufacturers like Statuses, Ultimaker. You know? So these are the companies which are into 3D printing, and these are the CAD software companies. Autodesk, Dassault System. HP is also in 3D printing, because it is giving you us 2D printers like lasers and all that. Now they are developing, though they are selling basically, or they are manufacturing 3D printers also. Okay, so they are also into this development of this format, which is a relatively new format, said to be new standard in the area of additive manufacturing, and it allows higher interoperability between 3D modeling software and other applications, platforms, services, and printers. Because you have to move through this chain from CAD model, you need to go for conversion, and then certain applications, because जो 3D printing companies, they will provide you some kind of software which will convert the CAD model information or STL model to the printing format. We will see in next few slides what is the process flow in that. Okay, so this is basically the when you generate such kind of or create such kind of a format. So that means you have to take all people on board. Otherwise, they try to avoid or put hurdles in your way. Okay, so you need more acceptability, and that is why the Microsoft took a right decision to bring on board all the companies, so that everybody in the chain that benefits and have good acceptability. So it is a these are the benefits of 3MF formats. It is complete. All of the necessary model, material, and property information is contained in a single archive instead of a two files which we have seen in the previous slide. So human readability easily can be understood by the human. Common structures such as OPC, GIF, and XML are used to ease development. And it is very simple. The specification is short and clear, making development easy and validation fast. Extensibility, leveraging XML namespaces allows for both public and private extensions while maintaining compatibility. And this is unambiguous. There is no, this is based on a clear language and conformance tests. And this ensures a file is always consistent from digital to physical. And accessibility, access to all to and implementation of 3M specification is and will always be free of royalties, patents and licensing. So no patents and royalties. So everybody is free. So that means it is more accessible. And so this is the comparison. Same model, you have a 3D, you want to 3D print. So one side you have a model, the CAD file of the STL file, which is requires you to have 28.5 megabytes. And if you have the 3mm format, that requires you just 11.1 megabyte. So this is the difference. So more than about 30 or 40% reduction in data, and the more is the data requirement or memory requirement is reduced, its interoperability or simplicity is more actually in this case in 3MF format. So this is the last one, VRML format. VRML format is virtual reality modeling language. It is pronounced VRML or by its initials in 1995, and this is known as virtual reality markup language. Is a standard file format for representing three-dimensional interactive vector graphics, and designed particularly with the World Wide Web in mind. Just like HTML file you can open in the browser, so same thing you can open this in browser. 3D model you can see in the browser itself. Suppose you don't have the software with you, you want to open and see the 3D model. You can see that using the element, which is again free. And nowadays, you may have heard of even Adobe has come out with 3D printing, just like they have a 2D print. You can convert your Word file to Acrobat Reader file, PDF file. So similarly, you have 3D PDF file where you can embed that 3D model in your PDF print. Okay, you can rotate it inside the PDF print, manipulate the model. Okay, so coming on to the a small case study that I have for simply understanding. I have the same geometric the same model that I showed you in the slide, and this is the triangulated model, and this is the machine that we have in our college, and this is a Raise 3D print, and this is the idea maker software, which is given by the software, the machine manufacturer itself, for converting STL file into the printable file. Now, once I give the STL file to the machine, to the this software for printing, it gives you, asks you what is the kind of extruder, means the material that you have, whether you want to go for high quality, standard, or speed. So remember, high quality means layer thickness will be less. Standard means normal. Speed means course. So here you see, when you have the high quality, you have the layer thickness say 0.10 mm. But as I go for speed or standard, the layer height is 0.15. Okay, and similarly, if you go for high quality, the layer thickness will be, say speed, it will be 0.20 instead of 0.15. Now, once you have this thing, it will show you the timing also. The moment you increase accuracy or high quality, it will show you the time that this is required. Time is more. Okay, so this is will tell you the layers, number of layers, 404. Okay, and this is the actually the you can actually have this section plane to see what kind of a layers you will have. You can move this plane, transparent plane that you are seeing. This is just showing you cut section or the printer will move. Okay. uh, so you can see the number of triangles 48, edges are 31. Okay, so this information is available. So this is giving you the slice information. Okay, so where see, this is the upper slice, this is the lower slice. Okay, lower, still lower. So all the, so basically you are starting from the lower end and then coming to the upper end. This is how you build the part layer by layer. And this is,
Sir,
you see, yes.
sir, I want to know that
Mm.
when we draw some drawings in CAD software,
Mm-hmm.
then firstly we will draw, then after we have to cut all the objects in the triangular sections, or we have to make by a triangular section, sir.
Oh, okay. I will just show you.
Yeah, yeah,
Let
yeah.
me open photos. Okay, I'll show you. It is better understood with the help of some kind of example. So let the software open. We'll continue with this. Uh, it takes some time. Okay, okay. I'll continue with this and come back when the software is over. Okay, now. Uh, Okay. Now you see, once you have this information, layer by layer information, that means the outside periphery and inside periphery, the information is converted by the machine into ANSI program information, because the nozzle which you are sending for depositing that kind of a material, or for that matter a laser which is which is scanning the material for certification, is nothing but a tool. Okay, so nozzle is, what is nozzle? Nozzle is, just imagine that as a CNC milling tool, and it is going layer by layer somewhere and depositing the material. The information is here nothing but in the form of, you see, the GM format. So I hope you have already gone through the NC programming and you are aware of. Okay, so this is nothing but the directions to the tool to go to particular locations. Okay, so that the material can be deposited. Okay, so let me. I think, I think it is giving some problem to me. Let it open. Okay. So okay, so this is how the tool direction to the tool, or the ANSI code for the tool movement, just like you have seen similarly. So these are some of the research issues that we have in CAD of 3D printing. You have meta materials, functionally graded materials, and graded porosity. Like you can manage the porosity, जैसे हमारे जो कोई भी part है उसमें density, if you have the casting, non-casting, the density of all of the object or the component is same. But when you are 3D printing, you can manage, because you are sprinkling some kind of a powder. So the powder intensity you can vary. Accordingly, the intensity of the 3D print or the density of the 3D printing can be varied. So these things are available, and people are searching in on these topics of bringing multiple materials or meta materials, functionally graded materials, where you can have different functions within the same component. Like you have density. Density is different in different areas. Okay, so you have mechanism how you scan the layers, because once you have the 3D model with you, you want to go for scanning. Okay, so scanning is with the help of say some tool. Okay, so how you are scanning, now you can scan it in a fashion which is like this, so that the material is solidified. So that is another research issues. And then materials like this, which are very complex, graded porosity, where you have porosity in one area is say here it is low porosity and here it is high porosity. That means open space is less here and open space is more here. This is also one of the research area that we have. And research issues, the metamaterials, just like this, the chips, electronic chips, circuit boards. So you have different materials embedded inside. Okay, so a metamaterial is a material engineering to have a property that is not found in naturally occurring materials. They are made from assemblies of multiple elements, fashioned from composite materials such as metals and plastics. Okay, so this is about techniques or technologies that we go on, but these are basically the research issues, because these CAD models, I think. Okay. Okay. And as I talked of functionally graded materials, if you can see the bone structure, for example, this is a femur, okay, and the human bone is an example of functionally graded materials. You see, the density inside the of the bone is not same throughout. Okay. Oh, sorry. Okay, so let me open this part first for your, and more or less we have finished our this presentation. Sorry, it is taking some time. Okay, okay. So you have, for example, sketch. I will make a simple model. Okay. So you have a small rectangle. Select this as a plane, and so this is a rectangle I made, and that's it. Okay. Now I am going to use this.
Extrude.
Okay, this is the feature that I have built. Okay. Now this is a okay. Let's extrude. Now this is a my geometric model, simple geometric model. Okay. Now what I am going to do, I am going to save this. So one option is save. So that means it will save your model. So whatever the format is, it is now saved, or it will ask me some kind of a name. So I will say YMCA. So this is, you see, SLDPRT. Okay. So it has multiple these options. You know? So you have you see 3.3 MF is there. Then who have dot AMF. Okay, and you have IGS, JPEG. It will save as image. STL. So you see STL. So this is STL file. Let me save. Let me first save it as a simple file, as a SolidWorks file. So this is okay. Now this is saved as a SolidWorks part file. So that means now I will say save as. So save as. Now I will save this as STL. Okay, so this is STL file. Save. You see? Okay. So this is saying me 12 triangles. So you can imagine there are 6 faces. So 2 triangles per face, and this is going to give me the file size and all that. And I'm going to say yes. Now I can go to my desktop. Okay.
Yes.
Okay. So you have this one. So you see, this is my part STL. Now I can open this in my to see what kind of information it has in Notepad. Say Notepad. So this is actually saved as binary. So it is not showing me anything. Okay. Now let me save this as uh, STL. Okay.
Sir, it is our own na, that from which part we have to select either STL or additive manufacturing and that type of code, sir.
Yeah, you can save this as in any of the file formats. You see, once you go to save as, okay. So this is save as options. You see, so you have DW. So many options. So this is suitable for 3D printing. 3D, sorry, 3D that I told you. Then you have AMF. You have like you know that this is JPEG, JPG. This is image format. So this is not going to use for 3D.
Yeah.
So you have all these file formats. You have STL, VRML, etc. And all these, even step file you can save. And you have, let me see again, STL. It is not showing me the option of, it generally shows actually the ASCII or binary format. Okay. So let me see, replace it. So this is saying say binary. So binary means it won't be able to, I won't be able to open it in Notepad. You see, and if you go to certain, there must be some options where you can say ASCII format. So it will give you the triangle by triangle. So 12 triangle, for each triangle you have the start point, end point. The meaning whereby when you have this model, this file, now this file is useful for your 3D. This file is useful for your 3D. Okay. So this is you can even use that in 3D Fusion 360 and all that to open that file and all that. So this is what we have for today. And research issues in this thing, functionally graded materials I was discussing. You can actually control the quality of the print over here and the quality or the density over here, so that your area which is in between these two articular, this they call it as articular region, where it is going to join with some other bone. Okay, जैसे ये knee के साथ आएगा इसमें से एक area. So this is say upper side or the lower side. This is upper side. This is, so this will go to the pelvis and this will go to the knee, for example. Okay, and they have different densities and material information. So if you want to build this kind of material, just like because nowadays you can have this kind of replaceable 3D prints of titanium, but they are of uniform density and uniform material basically. So what the researchers are now thinking, if you can exactly replicate the bone, that will be very good, because that will give you a feeling to a person for whom you replace the bone with a artificial kind of a implant. Okay, it will give a real kind of a feeling to that person, and this is you that is why the research is going on creating either functionally created materials. Okay, and this one is different materials layers, different material layers also. So these kind of meta materials where you have multiple materials in within the same component or model, different this thing, like porosity, graded porosity and all that. So you need definitely a higher quality of 3D printing file format. So which is can be accommodated by the latest and research is still going on basically to, so that 3D printing of these kind of issues can be handled. Okay, so this is a summary. 3D printing is. I hope your question is clear, Piyush. You have the STL file. So basically, you take the STL file, this STL file, in the attach it to the 3D printer itself. Okay, and it will. You have to select that file where which you want to print. It will do rest of the things itself. The only thing is you will have to choose कि आपको standard चाहिए, printing या high quality चाहिए या speed चाहिए, और you want to manage other things, है ना? उसको build कैसे करना है, that you can manage उसको, जैसे मैंने बताया कि you want to keep it horizontally or vertically. So those things you need to manage. Okay, but it is pretty easy. Once you have the only input required is the STL file, so you can take that as a print. Okay,
Yeah,
so this
sure,
is
sure.
all. Yeah. So rest of the things like slicing and all, you need not to worry. You don't need to do that manually. It is a computer which is going to do, but you need to provide those parameters which you want to use. That's it. Okay. So we are open to questions if you have any. This question time.
Sir, one more doubt I have. That
Okay.
is in your beginning slides.
Uh-huh.
I don't get it with that laser part, sir. Will you please open that, sir, slide, sir? Where the
Laser,
laser? Yeah, yeah, yeah.
laser scanning. Scanning. You mean to say this one?
No, sir.
Okay, this
Yeah,
one.
yeah, this one, this one. Yeah, this
Okay,
one.
okay, yeah, yeah. Tell me. Yeah. See, you have a. I will show you with the help of. Say. Okay. Okay. Let me open for a minute. I'll show you. Tell you that. Okay. Now you have an area which you want to print as, say, this one. This area you want to print. Okay. Now you have powder throughout sprinkled. पाउडर सभी जगह पर है, यहाँ पर भी है. गॉट इट. सभी जगह पाउडर है. देयर इज सम रोलर which is coming over here and putting the powder all over the place. सभी जगह उसने पाउडर फेंक दिया. ठीक है, एक लेयर बन गया आपका पाउडर का.
Yes,
Now
sir.
this roller will go back after sprinkling the powder. You have a very thin layer of, say, 0.5 mm. Now you have a laser gun which is going to throw light in this area only. Laser beam for sintering. ठीक है, तो it will come from here, come here, come here, come here, come here, maybe here, here, है ना. इस तरह से
Yes,
क्या
sir.
करेगी, सारे एरिया को कवर कर देगा. Now what will happen? This powder will solidify. Now what will do? This roller will again come and sprinkle powder next layer over it. Okay.
Yes, sir.
Now again the laser will come and scan the area where you want to print. The next layer is also printed. ठीक है. So likewise, every time the powder will be sprinkled and the laser will come, your platform will get lower every time. So you are building the part. Okay.
Okay, sir. Yes, sir.
So this is you can just watch some kind of a video of, and you will get more understanding.
Yeah, I had studied in also manufacturing, that electron beam machining type.
Yeah. Same thing.
Yeah.
So only thing is it is solidification here. Basically, you are solidifying. Whether it is a liquid, whether it is a powder, or maybe some sheet which you are cutting with the, so sheet by sheet it is going. So everything is just like. So anybody else want some comments or something? Want to discuss anything before we wind up?
Actually, sir, I am also enrolled in the research of 3D printer, sir.
Mm-hmm.
So, would you please suggest me that any material had been founded to change the nozzles material, because basically the nozzles are of made like a stainless steel substance and a brass and all. So, is there any material launched, sir?
Frankly, I am not, because my area is more towards the CAD and going into the manufacturing side. So
Yeah.
I think what your research area is more on the material side, I guess.
Yeah.
Side, na? So
Yes,
because
sir.
you see, it has so many technologies. Means somebody can take the laser printing, or even the path planning for the laser will scan like this area. So you have variety of methods by which you can scan this area. Either you take outer side first, or you take this zigzag way. Which area will be more optimal? Which method will be? So there are so many research issues, and it's very good that you are taking that aspect. Uh, but I don't have a ready answer to what you are asking.
Okay, sir. Thanks, sir.
Okay, thank you.
Bye.
So if okay, so if
Okay,
we don't
thank
have
you
any,
very much, sir. Thank you
okay,
for joining and enlightening us with such a wonderful lecture.
okay, thank you very much. Is it
And
Surinderji is speaking?
Ah, thank you, sir. Thank you very
Okay,
much, sir. Sir, very
o-
nicely explained 3D printing. Thank you very
okay.
much. Ah,
Thank you. Nice of
thank you.
you having given me opportunity to speak. Thanks.
Thank you.
Okay.
Thank you.
Thanks, sir. Your lecture was very innovative and and enrich my knowledge in the 3D printing field, sir.
Okay, thank you, Piyushi, and thank
Yeah,
you
yeah.
each of you participants for patient hearing. Okay, thanks. Bye.
Thank you, sir.
Okay.
so, thank you, participant. We will meet next session at 2:25. Please join well before the
Uh,
time.
I request to the Jitendra sir that please share this PPT to the organizing team so that we will fulfill to our work, sir. Hello.
Jatinder sir, there is a request for from the participant side. If you could share the PPT, and you will share with the participant. So, Piyush, I will convey your message to sir. Otherwise, we have recorded this session. We will upload all the session recording on YouTube. You can access from there also.
Okay. Okay, sir.
Okay. So thank you very much. We'll join at 2:25 in the next session. All please join. Thank you.
Okay, thanks.